Hello everyone, we are from Group 1, present the project of Dynamic BDA 20103. So these are our group, Ahmad Samir, Ahmad Fitri, Anderson, Anish Nasuha, Anish Shazwani, and the last, Junjin. Introduction of mini project. Motion description has been the focus of the aspect of physics that we have been learning about up to this point. The three fundamental characteristics of the particle in motion, location, velocity, and acceleration, have been examined. In dynamics, we observe the motion's causes. By examining these causes, which we shall refer to as force, we may gain a more comprehensive understanding of a physical situation. We may define all motion that result from a set of force using dynamics. As a result, dynamics serve as the foundation for the remainder of the study of classical mechanics and is used in all subfields of physics. The fundamental law of dynamics, 3 Newton's law, are introduced after the concept of force and mass are introduced to help one understand dynamics. The law is used to explain a variety of force, including gravity, friction, tension, and uniform motion dynamics. At some point in our life, we have all witnessed vehicles setting up. Wheelies are especially entertaining to watch in a motorsport like MotoGP, where riders frequently perform them after winning a competition. The wheelie is extremely dangerous if we do not have the skill and technique to make one as a front tire lift off the ground with the roar of the high-power engine. As regular people, we are not professionals or a rider that can do it easily as it seems. Acceleration during a wheel stand causes several force equilibriums to break, causing the car to ride on its rear motor. In this project, we will investigate how the kinetics of the rigid body, which we learned about in Chapter 5, applies to everyday life in engineering. As an example of rigid body plane's kinetics, consider the motorcycle. For the objective, to apply the principle of kinetic of a rigid body to demonstrate its theory of it in real life, to apply Newton's law of motion in the analysis of the data obtained, to investigate the relationship between calculated data and experimental data.
For the methodology part, introduction of methodology, this research will investigate the engineering use of rigid body kinematics in everyday life. As defined in Chapter 5, a rigid body is a body of particles that do not deform under load. As a result, in this research, we investigate the link between external forces and moments and the body's linear and rotational acceleration. Not only that, in this chapter, but you will also able to develop the planar kinetic equation of motion for symmetric rigid body and able to describe the theory used as well as the case studies for procedure. After discussion, we have selected a motorbike as the case study mechanism for our project. We shall look at the translation of a rigid body planar kinetics. The mass of the cyclist and the mass of motorbike will be treated as one stiff body. We were able to look at how mass can influence the maximum acceleration before the front wheel lifts off from the ground, sometimes known as the wheelie. The kinetic of a rigid body is a study of connection between external forces and moments and the body's linear and rotational acceleration. The mass of cyclists and motorcycle will operate as the external forces on the road in this situation. Newton's law of motion are critical components of rigid body kinematics. The main principle of motion that we will be applying to this project is Newton's law of motion. Newton's first law states that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at constant speed unless it is upon a force. Newton's second law is a quantitative description of the changes that a force can produce in the motion of a body. It states that time rate of change of the momentum of a body is equal in both magnitude and direction to the force imposed on it. The momentum of a body is equal to the product of its mass and velocity. Newton's third law states that when two bodies interact, they apply forces to one another that are equal magnitude and opposite in direction. The third law is also known as the law of action reaction. For example, the cannon will have an equal and opposite reaction of being pushed back as the bunny is being pushed forward. For the variable case study, we need to have 3 distinct sorts of variables to explore the cause and effect relationship of the experiment and then further analyze it, just like any other experiment and analysis. First, we have the constant variable, which specifies the component that will remain constant during the investigation. The following are the constant variables in this case study. There's the gravitational force exerted on a motorcycle, type of motorcycle, the height of the motorcycle, and the length of the motorcycle. Next, we need to have the manipulated variables. Manipulated variables are the elements that can influence the result and add variation to our input. The factors adjusted in this case study are listed as mass of the rigid body, which are the total of mass of cyclists and mass of motorcycle. Finally, there's the responding variable. The responding variable are the quantifiable outcome of this manipulation. The case study data that we can use for investigation and analysis. The following are the factors that responded in this case study, which are the maximum acceleration of the motorcycle just before the front wheel lifts off from the ground.
Hi, my name is Junjin. In this part, I will explain about the calculation. First of all, the formula of Newton's law of motion will be applied to the theory and calculation. Also, the process of obtaining the experimental data will be described in this part. So in 3.1a, we will assume that the mass of motorcycle rider is 50 kg with a total mass of 200 kg. So then we will calculate the distance of center of gravity. After determining, we will applying the F equal to ma in the calculations, and we will find the acceleration for the 50 kg of the motorcycle rider, that is 14.715 ms negative 2. And for the part B, we will assume that the mass of motorcycle rider is 70 kg and have a total mass of 220 kg. So again, we will determine the distance of the center of gravity first. Then we will using the center of gravity to determine the acceleration by using the formula F equal to ma also. So after that, the acceleration that we calculated is 14.715 ms negative 2 also. In part C, we will assume that the mass of the motorcycle rider is 90 kg. So with the free body diagram, we will determine the center of gravity, distance of center of gravity first. Then we will apply in the F equal to ma also into the formula, and we will get the acceleration of 14.462 ms negative 2.
Okay, this is the second, which is recorded maximum acceleration before wheelie. Also, we use for the mass of the rider 50 kg, 70 kg, and 90 kg. For mass of motorcycle plus fuel, also the same, 150 for the three maximum. For the three mass, for the total mass, 50 kg is 400 kg. For 70 kg, 220 kg. And 90 kg, total mass is 240 kg. And the velocity we use is the same, which is 40 kg per hour, and the time we got for 50 is 1.84 seconds. For 70 we got 1.91 seconds, and for 90 we got 1.94 seconds. For the recorded maximum acceleration before wheelie, for the 50 kg we got 6.04. For the 70 kg we got 5.82, and for the 90 kg we got 5.73. Okay, this is the graph of recorded maximum acceleration. Okay, as we can see, for the 50 until 70, the line become decreased at the 5.82, and then from 70 until 90, the line becomes more decreased at 5.73 because of the total mass that we use is different. Additionally, it would be advantageous to undertake measurements with more cyclists, including those of various ages, genders, riding experience level, and others. Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Anisha Learning Technology. My matrix number is CD210257. Today I want to continue for the data and graph analysis. Okay, for the data we got first for calculate maximum acceleration before wheelie, and second we got for recorded maximum acceleration before wheelie. Okay, this is the table 4.1 and the graph. Table 4.1, it shows the data of the calculated maximum acceleration, which is we use three different maximums, which is 50 kg, 70 kg, and 90 kg. For the mass motorcycle plus fuel, we use 150 kg, and for the total mass for 50 kg, 200 kg. For the 70 kg, 220 kg, and for 90 kg, we use 240 kg. Okay, for the graph, for mass 50 until 70, we got a straight line because they have the same calculate maximum acceleration, which is 14.715, and then for 70 until 90 kg, the graph becomes decreasing until 14.462 because of the weight obtained on the front wheel is very low. For this experiment, we use rider with three different mass as manipulated variables, which is 50 kg, 70 kg, and 90 kg. Different maximum accelerations caused by each mass can exist before the front wheel begins to lift off the ground. Based on the graph obtained, we got that the calculated and recorded data were different in value, but the graph pattern is the same, which is decreased. Okay, for the mass of the rider 70 and 90 kg, the calculated maximum acceleration is the same. The percentage of differences is 59.93%. The formula that we use is calculate acceleration maximums minus recorded acceleration maximums over calculate acceleration maximum times to 100%. For the mass 50 kg, we got 58.95%. For the mass 70 kg, we got 60.45%. And for the mass 90 kg, we got 60.38%. So total average, we got 59.93%. Additionally, it would be advantageous to undertake measurements with more cyclists, including those of various ages, genders, riding experience level, and others.
My name is Anis Nasoha binti Kasali. For this chapter, I'm going to explain Newton's second law. Newton's second law of motion states that the acceleration of an object relies on two factors: the net force acting on the object and the object's mass. The acceleration of the object is directly proportional to the net force acting upon it and inversely proportional to its mass. In brief, as the force pushing upon an object increases, so does the object's acceleration. As the mass of the object increases, the object's acceleration decreases. This chapter, we explore the relationship between mass and acceleration in Newton's second law of motion. First, force equal to mass time acceleration. In this chapter, we will further examine the percentage of variances between calculated and recorded data. Next, for this chapter, let's start with the element in the calculation. There are numerous essential components in the formula to consider, such as mass, the distance of the center of gravity, equilibrium of force law, related kinematic equation, and maximum acceleration. From the graph, it demonstrated that maximum acceleration could achieve the project's objective by propelling the motorcycle as its front wheels began to rise off the ground. We examined and restricted the risk situation for this reason. Due to the lack of measuring tools, certain forces and other variables are disregarded. Meanwhile, friction on the ground and rotation inertia were disregarded due to the lack of the information regarding the wheel structure. The graph depicts a straight line. As the rider's mass grows, the maximum acceleration before the front wheels begin to lifting off the ground decreases. Thus, confirm the second law of Newton, force equal to mass time acceleration. The relationship between the mass of an object and its acceleration when a constant force is applied is inverse. Given the nature of the acceleration value measured in this experiment can be considered mean value.
Assalamualaikum and good evening. My name is Ahmad Samir bin Samsudin and my matrix number is CD210346. So today I will present about the consideration and limitation of case study, the analysis process and the experimental procedure. Okay, first, the rotational inertia is ignored because we do not have enough information about the wheel spoke detailing. Next, the ground condition was overlooked because lack of equipment. After that, because performing a full wheelie is illegal and dangerous, we only study the maximum acceleration just before the front wheel begins to lift off the ground. Okay, next for the analysis process. The subject of the experiment in this simulation was the kinetics of a rigid body of motorcycle. When the motorcycle leaves, begins to move, an observation will be made. The center of gravity is a point in a body of matter where the total weight of the body is concentrated for ease of calculation. The center of mass is a position defined concerning an object or system of objects. It can be used to predict the behavior of a moving body when it is acted on by gravity. The gravity on Earth is uniform, so the object center of mass and center of gravity are both located in the same location. The center of mass and center of gravity of the motorcycle was located between the two axes of the wheels. The total weight of these two wheels will act on its center of gravity, which is located somewhere between the x and y axis when viewed from the side of the motorcycle. The center of gravity in the z direction has been ignored in this case because they will not be needed in subsequent calculation. As we can see from the figure, there is the center of gravity and the center of mass, which is W equal to mg. Next, the length of the motorcycle is also measured from the axis to the center of gravity of the motorcycle before determining the actual center of gravity as the motorcyclist rides the motorcycle. The same motorcycle was used while the manipulated variables is the rider mass and the constant variable is rider height, also as the motorcycle used. The formula used in this simulation is a force equal to the product of mass and acceleration, where acceleration is needed to be determined before the motorcycle front wheel is up. The frictional force acting on the tires will affect the force of the motorcycle on the x-axis. So, in the formula, force must be subtracted from the frictional force, while the y-axis must be subtracted from the weight. Here's the equation for the force. Next, you can know F equal to MA. Next, sum of Fx equal to Fa, which is follow the direction, and minus the frictional, the coefficient of friction of force equal to MAg. And next, for the sum of Fy, NB minus Mg equal to Ma. So as you can see from the figure, there's a moment at the center of the gravity, and when we start to calculate it when the front tire leaves from the ground. Okay, last, the experimental procedure. First, the 50 kg rider at the starting point is ready to start. Second, start the stopwatch as the motorcycle moves from the starting point. Third, stop the stopwatch when the front wheel of the motorcycle begins to lift off the ground. Fourth, record the time and speed of the motorcycle when the front wheel begins to lift off the ground. And 5, repeat the steps 1 to 4 by changing the motorcycle with different weights, which is 70 and 90 kg. That's all from me. I will pass the presentation to the next presenter. Thank you.
For the conclusion, in a nutshell, we have successfully studied the motorcycle as our mini group project for the application of rigid body kinetics. The concept of the kinetic of rigid body serves as the basis for this small group project, with the mass of a motorcycle and the mass of cyclists serving as the manipulate variable and responding as the external force on the road. By using all three Newton's law, which explain how an object's motion and the force acting on it interact to form F equal to ma, we look at how mass affects maximum acceleration, which acts as a respondent variable before the front wheel begins to lift off the ground. Error occurs during the experiment, such as the length of time it took to perform a wheelie. This is due to the fact that we time how long it will take the front wheel to lift off the ground or perform a wheelie using a radial stopwatch. Since a digital stopwatch can provide a more precise time measurement for these three parameters, we advise using one for this experiment to help reduce this kind of error. For three different types of mass, the maximum acceleration decreases as the wheelie time increases. This clarifies how their inversely proportional relationship came about. Last but not least, we can see that there is a significant percentage difference between the maximum acceleration that was calculated and the maximum acceleration that was recorded before a wheelie because of uncalculable factors that will still follow F equal to ma, which is Newton's law. We can draw the conclusion that the examined application help us better comprehend the chapter 5 material on the kinetics of rigid body. As the cyclist's mass rise, we can see that the maximum acceleration just before the front wheels begins to lift off the ground decrease. This can be related to Newton's second law, which states that is a constant force is applied to an object, the mass of the object will be inversely proportional to its acceleration, or F equal to ma.